Good afternoon and a warm welcome to everybody around the world. And thank you for dialing in for this 8th edition of the International Propagation Webinar. It's a special day. Actually, we would sit together with all of you in the World Horti Center. And we were already planning a great event over there with great visits, etc. And then something changed in the world that everybody of you have seen the impact of. And in the end, that forced us to come up with alternative ideas. One of the options was not hosting a seminar. And then we sat together with the organizing committee, and also we contacted some of the frequent visitors. And we said, yeah, one of the alternatives could be, for example, to do an online one. And actually, the responses were very positive. And as such, I hope that we can live up to that promise. It will never be the same as a physical event, of course. But I think in these strange times, it's the best alternative we can offer you. So yeah, we hope you enjoy it. To make it as comfortable as possible, most of you have received last weekend already some Dutch delight. We know we call it stroopwafels. They are typical Dutch cookies. And as mentioned in the postcard, we hope that with that delight having next to you, you are now allowed to open it up and eat it. So next to consuming all the knowledge today, you can also consume something sweet. Then before we start and go into the content, some practicalities. First one is I hope that the sound quality is okay. It's always a bit different from a distance than when you would sit in a room. So suppose you have any issues with sound quality or visually or whatever, feel free to make use of the question function, which you can see here in the screen. And in that way, my colleagues here behind the screens, they will help you to enjoy the webinar as good as possible. This function is also an important one, because at the end of the session, we will make use of it to address all the questions together with the panel of experts we have here in the studio. So you can make use of that as well for all your questions. The session is about to be scheduled for 1.5 hours. I know that in the invite, it might have looked like it was lasting till 5:30. So for those who have reserved that time, you have 1 hour extra today. So that's also already the first gift that we give you. Then a last practical thing I want to show you is voting. Because, yeah, it's nice to send information, but that's not the way we want to host the event. We are just as curious to your opinions instead of only listening to our own content. So what we will do during the presentations, we will sometimes kick in with some poll questions to check your opinions. And we will not do that by the computer, but hopefully you have your smartphone at hand. So I would like to test that quickly with you with the first test question. You can do that in simply 3 steps. One is take your phone. Second one is to go to sendsteps.me. That is the website where you can access the poll. So you just put it in the address bar of your internet browser. And then it goes to that website. And in the empty field, the login code Grodan 2020 should be entered. When you do that and access it, then if correctly, you should now see the following poll question. So maybe that's good to warm up and to check if this works. And the first question is actually a question which refers to our own. It's a simple question. Where is the Grodan headquarters based? Is that answer A in Chicago? Is it B in Roermond? Is it C in Toronto? Or D in Warsaw? So I'll now give you 5 seconds to answer that question, and let's then see if most of you have managed to answer it and whether you answered it correctly. So in 5, 4, 3, 2, 1. Let's see if we have some answers in. Voting is now closed, and yeah, we see that most of you have managed to answer the question, and I see that most of you have also answered it correctly. We have a 80% score because, of course, our headquarters is indeed based in Roermond. So that was good that we practiced this. Later on during the seminar, my colleague Thomas Peters will take you through all these poll questions. So good to have your phone next to you and know that you don't need to go to that website every time. If you just keep your phone open or next to you and you keep the website open as you have it now, then you don't need to log in again. And else it's as simple as going to sendsteps.me and entering Grodan 2020. Then, yeah, maybe I've told already a lot, but usually I don't like to talk about myself, but maybe quickly. My name is David Peters. Most of you know me because last year I also had the opportunity to be the host of the International Propagation Seminar in The Hague, and today, of course, that's my role as well. I'm active as a product marketing manager at Grodan, now active already almost for 5 years. And yeah, from my role, I am one of the persons to organize this nice event. I don't do that on my own. I do that with 2 colleagues. One of them we will see back later on as one of the presenters, Thomas Dauma, one of our international crop consultants. And the same counts for Thomas Peters, who we will also see later on. That's maybe a nice bridge to introduce him quickly, because Thomas is also one of our crop consultants for the propagation segment. But today he has another role additionally. Thomas will be the moderator. What does that mean? So the poll questions, he will introduce to you and take you through that. And at the end, he will also host the Q&A session. So know that if you have any questions during the presentations, you can simply type them in the question function, and then Thomas will pick them up at the end of the session. Then maybe a quick introduction to the team. Back to the roots. You might seen it in many of the communications. Why did we choose that team? First of all, roots is, of course, something which is very close to our heart. Grodan is, of course, active in root zone management. But next to that, we've also listened to many of the suggestions that we got last year, and then this was a typical topic that came back very frequently. So that was one of the reasons. But another reason is, of course, a lot is happening in the area of root zone management and in the roots. First of all, you see that if you look at the developments worldwide in propagation, then you see one of those trends is that less and less chemicals are allowed. That means also that we have to start practicing with other type of elements, and that will for sure come back in one of the presentations today. What we also see is that the systems in which plants are being propagated start to evolve. Traditionally, it's mostly on the floor with ebb and flow systems, but we now also start to see much other systems, and that is also one of the topics of one of the presentations today. Finally, of course, yeah, it's in our own genes. So my colleague Thomas Dauma at the end will also present something about the latest developments in root zone management and also related to our product assortment. Yeah, if I already explained you quickly the agenda of today, you see the names also. We have a diversity of type of speakers, as you see. We start with a scientific researcher, Marta Streminska, from the Wageningen University and Research Facility. After that, we have a person coming from a more practical area. One of the persons who is one of our customers from Roeland's plant. And then we end up with ourselves, with my colleague Thomas Dauma. So you see we have chosen different type of areas, and also some more pragmatic type of topics and some more strategic oriented topics, because we know the people who have dialed in also come from different backgrounds, so in that way it's relevant to all the people that dialed in. Having said that, I think it's time to go to the first speaker. So Marta, you can come forward. And we are very delighted to have Marta Streminska here in the studio. active as a researcher at the Wageningen University and research facility. Focus area, and for me as a marketeer, that's sometimes difficult to understand, microbial ecology. Something must be difficult also to explain to your children. But what it means in practice, how I at least translate it, is that you focus on research in themes like microbiology, water quality, etc. We are very happy that with your extensive experience in roots in effectiveness of biological pest control methods, you were willing to share some of the insights in that. So with that, I'll leave the pointer here, and then I'll hand over the word to you.
Thank you very much for giving me the chance to introduce you to a topic of microbial ecology in the greenhouse systems. It is, as you may suspect, a very important part of the greenhouse system, but it was in the past often a little bit overlooked. If we look at the soilless culture, we know that there are some pros and cons of this soil culture compared to the soil cultivation. Of course, the pros are, for example, that the cultivation is possible where the soil is not suitable to cultivate crops. We can control a lot of things about the watering, about the quality of the plant material. We can start without the pathogens if we really make sure that all the elements that we use are clean. And of course, that are the plus points, but there are also a few negative points. For example, the fact that there is a little of microbial buffering in a system. Depends, of course, on the type of the substrate you're using, but with inert substrates, the beginning of the cultivation is very important to make sure that there are no pathogens coming into the system and making the plants sick. And of course, this kind of systems are introduced, are very susceptible to pathogens that are introduced into the system, for example, with water. So pathogens that have, for example, spores that come with water. And we have the first poll question for you.
Yes. So I think it's time now to answer the first poll question. So what my colleague told you before, we have made some poll questions for you at home. So take your smartphone, go to sendstep.me, and please give your thoughts about the first poll question. And the question is, which of the following growing substrates do you expect are sterile? Is it A, rock wool, B, peat, C, cocoa coir, or D, none of these substrates? I will give you 10 seconds for the first question, so please start voting now. 5, 4, 3, 2, 1. If I'm right, I see the results behind me, and that's a good score. So 75% thinks it is rock wool, and 25% thinks it's none of these substrates. So Marta, please can you tell us something about this?
Yes, of course.
Yes.
I see that most of you got a part of the question well. So the rock wool is indeed a substrate that at the beginning is sterile. But if we begin the cultivation with the plants, giving them water and so on, in a greenhouse, it will not stay sterile very long. But is indeed in the beginning the sterile one. What is very important is that we have to switch our thinking from sterility of the system to pathogen-free system. Because there is no possibility to have a sterile system, even if we do a lot of things, because microbes come in from different places, even from the plant material itself, even if, for example, the seeds were sterilized and so forth. What is very important is that if we look at the different substrate, of course, there is a difference when it comes to chemical qualities of this substrate, but also the biological qualities of the substrate, which are connected very often to the chemical qualities of the substrate. So, of course, if we look at the inert substrates, we'll have a lower complexity when it comes to the chemical qualities, and also lower biodiversity in the beginning of the cultivation. But this biodiversity we can influence, for example, through adding some of products like organic substances, or adding even microbes that will colonize roots quickly. So this all, in the end, can be, of course, influenced, and biodiversity can be higher. And if we look at the reused substrates, which I will come back on later, these are also very biodiverse, and can be also very important when it comes to preventing the root diseases. So if we talk about the microbes in a system, we used to think about the plant and the microbes that we can actually divide it to. So we can have a plant without the microbes growing around it or in it. But at the moment, more and more researchers, but also people that work in greenhouses, begin to think about a different way of approaching the whole system, that we actually look at the plant and the microbes that are connected with it as a holobiont. Because you have microbes everywhere, from the roots, from the seed, but also even on the surface of the leaves and so forth. There are microbes in the air, microbes in the water that you give your plants. So what's important, that you prevent the pathogen from entering your system and making your plant sick, but not prevent all the microbes getting in, because they are also important for the growth of the plant. And then we have, one more poll question for you.
Okay, I will break in slowly. We have another poll question for you today. So again, please take your smartphone, go to sendstep.me, and with the password Grodan 2020, and please give your thoughts about the following question. So, which of the following type of culture contain the highest amount of bacteria? Is it A, soil, B, organic growing, C, rock wool, or D, NFT? I will give you 10 seconds again, and voting starts now. This is a hard one, so 5, 4, 3, 2, 1, and voting is closed. So what are the results? So that's quite interesting. So more 50% think it's soil. Almost 50% thinks it's organic growing, and maybe one vote thinks it's NFT. So Marta, please can you tell us something about it? What's the real answer?
Yeah. Then I will go to my next slide, which is actually about what kind of microbes are present in different systems. Of course, if you look at the soil system, this is the most diverse system that we have, and it's very difficult to actually mimic it in all its diversity and complexity in a system which are taken out of the soil. And this is also the system where the most microbes will be present. But we have to also make a distinction between the soils that are organically managed and the soils which are managed in a traditional way with a lot of pesticides, for example, because these soils will also have a lot lower biodiversity in them. And if you think about it, that actually in a cubic centimeter of soil, we have around a billion of different microbes, bacteria, fungi, and so forth. These are very huge numbers compared to what we actually can see when we plate these things when we culture them in the laboratorium, because it's maybe about 1% of these microbes we can really culture in the lab and study them. So about the rest of them, we know, for example, their genetic sequence, thanks to all the molecular biology techniques that we have available now. But we very often don't really know what they actually do in a system. So this is very important to also think about, that even if you don't see the microbes in your system, you don't see the fungi growing on the substrate, the fungi are still there, the bacteria are still there. And of course, there is a huge difference between the substrate. Organic substrates are thought to be more diverse, but it really depends on the type of substrate, because you can have like 1,000 of microbes per cubic centimeter to maybe 10 to the 8 per cubic centimeter. It all depends how much carbon is really available for the growth of the microbes. And rock wool in the beginning of the cultivation is, of course, the numbers of the microbes are lower, but when the plant is growing, producing a lot more root exudates, there will be a lot more microbes coming in and setting into the system. And these microbes, of course, have a very important role when it comes to the growth and development of the plant. If we look at the rhizosphere, so rhizosphere is actually physically around the roots of the plant, a few millimeters around the roots. This is very important when it comes to the growth of plants, because this is where a lot of things happen. Plants, some species, even 40% of their carbon that they actually assimilate through photosynthesis, they actually produce put it back into the system via the root exudates. So it means that there is a lot of food for the microbes around the roots to develop and be active. And this is very important, and sometimes in a substrate you have maybe even 10,000 times more microbes around the roots in this millimeter distance from the root compared to the rest of the substrate. So it's not only important to just check a substrate somewhere, but also check really close to the roots, because that all things are actually happening. If we look at this graph here, we see how is the concentrations of the root exudates and in a system. So if we have a system like a rock wool or a substrate-based system, these root exudates will not travel a long way. So a lot of them will stay around the root. So it means that there the microbes will be growing the quickest and more active. And if we have, for example, a system based on water, then the root exudates will be transported on the longer distances. But of course, these are not meters or so, these are centimeters or tenths of centimeters. When we look who's in there, it's a very difficult question, because we know a lot about the soil. The research on the soil has been going on for 30 years or more, even at the moment. We have new techniques based on DNA, so we can learn a lot about what's in there. But there is really not a lot of research done on the greenhouse substrate. So we have a little bit information about organic substrates, because they were the first that people thought, oh, there will be microbes in there. But there are also microbes in the rock wool systems, but we still don't really know much about them. If you look about different substrate, this is actually an example of different kinds of bacteria that are in different substrates. Different color means the different group of bacteria. And these are only organic substrates, which I have here, from core fibers, wood fibers, and different peats. So as you can see, when it comes to what kind of species of the microbes in there can be a lot of difference. But it's also, of course, important, do they have the right functions that are needed for the plant growth and development? So we have another poll question.
Thank you, Marta. Really interesting. So then we go on with the last of the third poll question in Marta's presentation. Again, take your smartphone, please, and give us your opinion about the following question. Which of the following aspects do you expect have a positive contribution on plant development? Is it A, plant growth promoting bacteria and fungi, B, plant pathogens, or C, human pathogens? So again, give you 10 seconds, so voting starts now. 5, 4, 3, 2, 1. And stop voting. And here we see the results. So 80% think it's plant growth promoting bacteria and fungi. It's good to hear. And 20% thinks it's plant pathogens. And no one thinks it's human pathogens. So Marta, please tell us something about it.
Yeah, of course. The first group that comes to mind when we think about plant development is, of course, the plant growth promoting bacteria. But these are not the only microbes that are important for the plant development. If we look at the microbes that are in the system, we kind of group them in a three, the most important groups. So the good ones, the plant growth promoting bacteria and fungi, the bad ones, so plant pathogens, and also the ugly ones, possible pathogens for humans. This is very important also when it comes to the crop that is actually going to be eaten, for example, the people. We have the good ones. What do they do? They're very important when it comes to degradation of organic matter that is present in a substrate. It's, for example, important for the organic substrate because this is also the food in the end for the plant. They're important when it comes to nutrient availability. We tend to think that in a substrate-based cultivation that we have all the nutrients optimized to the very good level, and that's in most cases, the true thing, but there are sometimes a little bit of problems like the change in a pH, when, for example, some microelements become less available for the plant. And in this moment, the microbes can be very important. And of course, there is also a lot of going on at the moment about the circular economy, so reusing as much as possible for example, of sources of nitrogen for the plants, so using biological fertilizers. And we need microbes to actually transform them into the forms of nutrients that plants are available to uptake. We have also plant hormones. This is very important because we think that plant is the only one able to produce its hormones and just direct its development itself. But the fact is that there are a load of microbes which are also producing hormones like auxins, gibberellins, and so on. So they also can influence very much what is going on with the plant and how is the plant going to grow. Is it going to put more energy into producing roots, or is it going to produce more flowers, for example? And we have a very good example of ethylene producing bacteria and bacteria which actually also degrade ethylene, so they can for example, have influence on development of fruits and how quickly the plant will develop the fruits. And we have also a little bit influence on abiotic stresses. So, for example, a higher salinity of a higher concentration of a given nutrient, which is normally not very good for the plant. But the very important thing where the microbes come in is also the plant diseases. So the bad guys and indeed the good guys which prevent plant diseases in a system. When we look at the different pathogens, I only focused here mainly on what's going on in the root system. So we have oomycetes. They used to be included into the fungi, but they are not exactly the same as fungi. So here we have Pythium, Phytophthora, different species which will actually cause root rots and dumping off of the very young plant material. Very difficult because they produce spores which can actively move in water, so so-called zoospores, so they can travel from one plant to the other and cause more and more problems. And then we have a group of fungi, for example, Fusarium, which will also cause root rots, wilting, and discoloration of the plants, and so on. And we have also bacteria, bacteria that will cause rots, but also can influence the growth of the plant because they manipulate the DNA of the plant, like, for example, Agrobacterium. So these are only the examples, few examples of possible pathogens. But what can we do to prevent them? Of course, there are different steps that we can take to prevent the pathogen being present in the system. The first step is, of course, the starting material, that we have to make sure that it's actually disease-free. So very stringent hygienic protocols for the production of the plant material are needed. We have also hygiene protocols during the production, so during the propagation, making sure that the feed water that the plants are being given, it's properly properly prepared so that no pathogens will be present in there. We can also disinfect the feed water, but you have to be really careful about the product that you're using. There are, for example, products that are more active against bacteria and will not really have influence on fungi. Example of this kind of products is products based on chlorine that are very good for killing bacteria, but fungi can actually survive quite a lot of when the concentration of chlorine containing products is high. We can also focus on the plant itself through induced systemic resistance of the plant and manage the natural disease suppression in the system. Of course, if we talk about the disease control, we can go to the traditional chemical disease control, but we can also maybe look at the biological one, which is also the last few years the most important part. Why biological control? Because the chemical control is becoming less and less available. For example, for the bacterial diseases, we are not able to use antibiotics in the EU. So it's difficult to actually prevent bacterial diseases except for hygiene protocols. The other reason is also sometimes insufficient efficacy of the chemical products, because the pathogens also can develop resistance against some of the products. And examples are for the few last years is, for example, Fusarium in different crops, which are being more and more resistant. And of course, societal issues, so people are more and more involved in the whole production of the crops, and they want clean crops without the residues of the chemicals. So environmentally friendly, robust alternatives are needed. So the first is induced plant resistance. It's all about making the plant defend itself. Also in this system, the bacteria and fungi are very important. For example, bacteria that are around the roots and produce hormones, plant hormones, can influence the plant that they will be less susceptible to disease. The other is disease suppression through the growing substrate when the pathogen may be present, but there will be no disease. This is example of it. We have fusarium in peat substrate, and the plant in this example is an eustoma, is getting very sick. And the peat with addition of compost, the fusarium is also present in the system, but the plant is not getting sick. Why is it happening? Because the plant is using the microbes that were present around the roots to form biofilm around the roots and make it survive better. And this is also one of the very difficult examples of the disease suppression via growing substrate. It's the example of reused rock wool with Pythium aphanidermatum in cucumber. Here we have a new rock wool. Pythium was put in very quickly into the system, and reused rock wools, we have a very low disease. This is reused rock wool, which was sterilized before the second cultivation, and it also has very low disease suppression. So it means that there is a role of biology in the system. The biological mechanism of the suppression could be antagonism with antibiotic production, parasitism, and competition for the niche. We can also influence it through using the microbial and biochemical pesticides. So pesticides that are based on the living organism, bacteria or fungi, usually on a very specific strain. Not all bacillus strains will be, for example, active against disease, or not all trichodermas. Microorganisms in these products are, of course, introduced into a new environment. So it's very important so they can colonize the roots very quickly so they can survive. And these microorganisms need registration as a plant protection product. So in conclusion, soilless cultivation is nor sterile, and nor should we be hoping for being it sterile. But it can be disease-free, of course, and the combination of measured chemical treatment, but also biological treatment, can have very good effects. And microbes are, of course, important for reaching the goal of good production. Thank you very much. And if you have any questions.
Thank you very much, Marta. Really inspirational to hear your story. For time reasons, we'll address them at the end. So feel free to take place at the table where we have the panel sitting. But it was I'm sure that a lot of people are sitting inspired behind their desk, listening to these stories. So I'm also curious about the questions that will come up because of that. After this first presentation, it's now time to go to the second one. And the second one is a bit a different angle, because first we had some scientific character of presentation, and now we are really going to more into, I would almost say, the most important, because in the end it's all about our customers and about our own propagators. And we had we were the big lucky guys to have one of them being willing to tell something about their experiences, and that's Roland's plant. And we have online, and I do not know if you can bring that into the picture, but it looks like he's sitting here in this studio. We have Edward Thoren being present. Thanks for being here, Edward. And Edward is the head grower of Roland's plant, which is one of the largest young plant propagators in North America. So we are very happy to have you here. And yeah, you can think like, oh, will he present live? And that was also our first thought. But with a connection towards Canada, it's already difficult to answer questions. So we said, you know what? We do the presentation in advance. So you are about to watch a recorded video in which Ed is one of the persons playing a role. And also a person you might remember from the last propagation seminar. That's Jack Jack Mooney. At that moment, he was still working for Costa Group, and he's now also active for Roeland's plant. And they will tell us all about the topic of propagation on concrete floors versus growing tables. And I would say have fun with this interesting video.
G'day, my name is Jack Mooney. I'm a grower and business management intern here at Roland's Plant Farms in Ontario, Canada. And welcome to the 2020 Grodan International Propagation Seminar. So sit back, have a cup of coffee or a glass of wine, depending on where you are in the world. Ed Thorne and I couldn't be more excited to tell you about our growing system.
Hello, I am Edward Thorne, the head grower at Roland's Plant Farms. I was asked by Grodan today to speak a little bit about our roots. At Roland's, we have 3 systems of irrigation.
We have an ebb and flood concrete floor design. We have an ebb and flow cascade floor design. And we also have an ebb and flow cascade table design.
Our newest innovation are grow tables. In 2018, we built this system to improve upon our propagation. In the past, we were growing on concrete floors, which has many advantages. But as we move towards the table system,
we get much more generative steering capacity, and the roots in the block is a much more vibrant, better, healthier root system.
Partially to do with the cleanliness of the tables, also because the root temperature is brought back to ambient at night. On the concrete system, we are measuring 10 to 15 degree warmer temperatures at night opposed to the table system. This table system has allowed us to have a naturally active climate. The air is allowed to move through the troughs, removing the microclimate you get at tighter spacings. By having the steel-based trough, it allows for a less porous growing surface opposed to concrete. I always like to say, when you pour a glass of wine on a concrete floor, that it stains, and you have to scrub it out. On this system, if you were to pour a glass of wine, you could clean it right off. And that's the same for disease pressure on these tables.
One of the many benefits of the table system is that the working is at height. So all the labour is done at hip height, reducing the need for people to be bent over working on the ground.
Although this system has its advantages, it also has many limitations.
The limitations are more focused around the labour and less on the growing side. There is a limited capacity of how many plants we can deliver to the labour for crop work, including elastics, and also for shipping.
For example, when you want to ship every half hour to a customer, you need to plan ahead the day before or hours before to meet these deadlines. The plants per person per hour being shipped from the tables is the same as the concrete. However, at the packing line, there's only room for 30 to 40 people. Whereas in the conventional concrete system, you can have as many people as you have available to complete the task. This table system is an excellent way to grow plants and allows us to automate a lot of the tasks to be done here at Roland's. As you can see, the plants are very straight and are placed here robotically. This opens a window for future automation. This allows us to easily design a system to clip, ship, pinch, and so on.
The table system is really automatic, and the potential for future growth is incredible. It all starts here, where we have the seeding happening at the seeding line, growing on the ground. We then have a spacing unit where we can actually transfer the plants from the concrete floor design into the table system. In this machinery, which is developed by Fleer Industries out of Holland, we're able to scan the plants and decide on a first grade, second grade plant, and we're able to use the machine to then space them at whatever density we require onto our tables. In our table system, we have roller conveyors that will bring it down into the greenhouse, into the growing area, and this is where we can adjust with our computer the generative or vegetative climates that we wish to obtain depending on our customers' requirements. We also have many other automated processes with our tables. We have a respacing machine where tables will pass through this machine, they will be picked up and then spread out further again to the required density for finishing. This enables us to have far greater throughput in this system. We can maximise the investment that Adrian and Jody, our owners, have put into this system by making sure we have as many plants as possible utilising this space. Another system that we have, which is a great feature in the automation of the table system, is we have a washing system. With this, the tables are elevated, they are washed with peroxide, the system is fully clean, and we're not able to have reintroduction of Pythium and pest pathogens into the growing area.
We find that the table system spreads less Pythium and Fusarium because those troughs are isolated to just one row of plants, opposed to on the concrete floor where water is free to flow throughout the plants. What we noticed in the summer months is the tables will get very warm, but in the night will return back to ambient. This is helping with our root zone and allowing the plants to cool off and create a generative action. The irrigation system is also much drier, as the water has to move through the plants and the capillary action of the block is being tested. This is where NG 2.0 has helped us grow a more even and consistent plant. The NG 2.0 block has received more water after irrigation than the Delta. As the plant grows larger and we dry down each time, the block re-wets continuously back to 800, opposed to the Delta that has a 700, 750. Thank you for joining us, and I hope you've learned lots from this presentation.
Rollins and Grodan, together, a driving force into the future of farming.
Welcome back, and I hope you enjoyed this video. I at least did it, and I hope also from the content being shared, maybe it gives you some inspiration to start doing things different tomorrow, or it might trigger ideas. So hopefully it is learningful from that respect. Having said that, this was the second presentation, and that means that we are going to the third one, and that is also the last presentation, and that will be done by Thomas Dauma, who will join me here, and that gives me the chance to introduce him quickly. Thomas is also one of our international crop consultants, active for 2 years at Grodan, and comes from, besides a horticultural background with studies, comes from a horticultural family, so he was almost born in between the young plants. So if there's somebody who can tell us much more from the Grodan perspective about how to propagate most optimally, it's Thomas for sure. So with having that said, I would like to give over the word to Thomas with the title of his presentation, Back to the Roots with Grodan Plant Top.
Well, thank you, David. Thanks also for reminding me of the period where I had still hair. But yes, it's me, so I'm the guy from the picture. But let's go to another slide, because that's better. So yeah, back to the roots with Grodan Plant Top. Actually, it's a title which has a double meaning, because yes, we want to focus a little bit more on the roots within this presentation as well. But I also want to, let's say, stress some points where we say, okay, we want to go back to the roots, but what do we as a propagator, or you as a propagator, have to do to actually benefit from all those benefits that a plant top block can have? So I hope that at the end you will get some, let's say, take-home messages where you can still think about. So yeah, a little bit of background before I start. So where as Grodan do we come from? So in 2004 we let's say implemented our Delta technology. Within the propagation business, it's known as the Delta block. Then in 2007 we came up with the NG technology, the next generation technology, within the propagation world known as the plant top Delta block. And within 2016 we now have our NG 2.0 technology, next generation 2.0, which we nowadays call our plant top block, but is formerly known as our plant top NG 2.0. For you as propagator, it's more or less, we came from a Delta, which is not really a capillary block, which I also heard within Ed's story and Jack Mooney's story of a Roeland's plant, which we just watched. We made a big step within our next generation technology, our plant top Delta, within 2007. But some of you also may know that we had some difficulties with wetting up at some propagators. That took some problems, but we have taken them away with our NG 2.0, where we now have a block that's very capillary and also easily initial saturated. So we go to the next one, and that actually what we want to achieve as Grodan is that we have a total concept of our products. So that means that we now have implemented our NG 2.0 technology within our whole product range. So this means we have now our NG 2.0 within our plugs, our blocks, and also our slabs, which in our opinion is the best combination that you can have, and also within your whole, let's say, production cycle. So yeah, advantages of this new technology. A uniform distribution of water content and EC in the top layer of the substrate. And actually that's one thing that we also stress, is that top layer where we always talk about, not only within our substrates or our slabs, but also within our blocks. And I know this is a picture which is drawn, but actually what we see is that we get a lot more root development here on this space within the slab, so in between blocks on the top layers, but also during the whole production phase within the blocks we see a lot more root development and root activation as well at the top of the blocks. So actually we managed to, let's say, make more use of the whole substrate volume, as you can say. So yeah, to actually put this a little bit more into perspective, we have some graphs, and this graph, represents the water retention curve. So yeah, I can expect that you say a water retention curve. What is that? I'm gonna try to explain it very easily, or by an easy way. So in this graph, you see two graphs. So we have plant top and non-capillary wool. So in this case, it could be, let's say, a delta block. And we have, let's say, on this axis, we have the percentage of water content that's present within the block. And on this axis, we have our suction pressure. So actually what we do within our lab at Grodan, we have a sand bed, and then we can apply different, let's say, levels of suction pressure to different kind of blocks. So here we go from, let's say, 0 to 5 kilopascal, as we stated here. And we made a comparison between our plant top and our non-capillary wool. So very general, with a suction pressure of 1, we have 73% of water content within our plant top block. Also a suction pressure of 1, we have 45% water content within our, let's say, non-capillary wool. 2.1, 32% at plant top, and 2.1, 10% at a non-capillary wool. In practice, I know these are all numbers, and then you ask, yeah, well, Thomas, what does this actually mean in practice? Well, you can actually say that if we, let's say, put a block on a slab, it more or less works the same as, let's say, the sand bed that I already talked about. There's a certain suction power from the slab to the block. So this means when you actually steer, let's say, on a slab, your water content levels within the block will also, let's say, go up and down. So for sure, you can imagine if I get a higher water content within my slab, my block will also have a higher water content. If it is lower, then also your block will get lower. But this graph actually shows, okay, so if I, let's say, have a certain suction pressure, let's say it's 1 in my slab, so it's pretty high. I get 73% in my plant top block and 45% in my non-capillary wool, if I have the same comparison at that time. But if I steer, let's say, lower within my water content in a slab, what happens then is that we see, okay, we have, let's say, a pressure of 2.1, so go lower in water content within the slab. We see that the plant block still holds 32% of moisture in the block. But if we look at non-capillary wool, we go to 10%. That means that actually the whole function of the block at that time will be lost. And that's also where we see big differences the last time, let's say within the differences between the different type of blocks. So actually we think that this NG 2.0 technology results in a high quality propagation block. And for those who did not know it yet, but we have also a new branding, that's the new Grodan green. And as I also said, our plant-top NG 2.0 is now called our Grodan plant-top. So yeah, what are actually the benefits for the propagators? Because I'm now presenting for the propagators, so you think, yeah, Thomas, you can tell everything about the production side, but me as a propagator, what's my benefit? Well, there's a lot on this slide, but I will, let's say, highlight some points. And I will come back on that later as well in the presentation. But optimal steerability of water content NEC. So actually, we always say, we always state, yeah, precision growing. We need precision growing in our lives because then we can actually steer the crop. But that also means that within a propagation facility, you as propagators also know, we have a lot of, let's say, plants within one bay. So that means that we have a lot of variety between the plants, between also the blocks. So what does that mean? That we also need a block that's very uniform. So one block can be, let's say, 50% water content, but if the other one next to it or on the other side of the bay is, let's say, 30, how can you as a grower decide to go, okay, now I want to precision grow and I want to steer maximum on my blocks? So that's one thing that we really looked into developing this block, that we need, let's say, a low standard deviation on our blocks, but I will come back on that later as well. But also, let's say, more steerability on, let's say, the water distribution within our block. As I said, we managed to actually get more root development within the top layer of our blocks and also our slabs. So we actually want to use the whole substrate volume. And that also, let's say, results in more steerable plant, more steering possibilities as well. And what I also stated is that the initial saturation of this block is also better than before. So due to the lack of the dry spots, the block is much quicker saturated, and also within the resaturation time we gained a bit. And also that's one thing that I will come back to as well. So I think now we have something for my colleague Thomas. Thomas.
I think it's a little bit time for some interaction again. So please take your smartphone again, go to sendstep.me, and then if I'm right, the following poll question will pop up at your phone. So our question is from Thomas and me. So what is for you as a propagator the most important benefit? Is it A, the good uniformity between the blocks, B, uniform distribution of water and nutrients over the height of the block, and C, active pen roots underneath the blocks? Again, I give you for this one 20 seconds, and the time starts now. So 5, 4, 3, 2, 1. Close the poll. And if I'm right, the scores are behind me. So that's quite interesting. I'm happy to see this. So 64% say it's the good uniformity between the blocks is the most important point for them. 32% think it's the uniform distribution of water and nutrients over the height of the block. And 4% thinks active pen roots underneath the block. Now, Thomas, tell us something a little bit more about this.
Yeah, I will. Thanks. Well, actually, it's quite a tricky question, and I think there will also be people that say, well, why is there not a fourth option where it says all of them stated above? So I would say, yeah, actually, the first point is very important. I'm lucky, I'm happy that, let's say, a lot of the viewers choose this one. So good uniformity, yes, very important. Uniform distribution of water and nutrients over the height of the block, also very important. And I would say also active pen roots underneath the block, I will come back on that now, is also very important. So yeah, what do we want to see when we actually deliver a plant? For me, I would like to see also very active pen roots underneath. And then where do I want to see them? I want to see them within these grooves that you have underneath the block. So here as well, this is a groove as well. These roots over here and these ones, they will eventually do it for your customers. So when you deliver the plants, those are the first roots that will penetrate the substrate and will take up the nutrients out of the slab. So actually I would say also pay attention to, let's say, those type of roots, because those are the most active ones at your customer as well. These all you see over here, all you see over here at the top of these grooves, they will eventually die off, but it's those are important. Yeah, so then I have another graph, and it's actually, yeah, I think good to show, because Ed he also told in his story about, let's say, the development that's been going on between, let's say, NG 2.0 and also NG technology. So here we have a graph which compares our plant of Delta and our NG 2.0 at, let's say, a trial that we did. So we have a grafted two-header in plant top and plant top delta. So what we actually see is that the resaturation of our plant top block is 5% higher compared to plant top delta. And that also plant top is more, let's say, eventually steerable and also was more uniform. And what we can also conclude here is that actually our plant top block, so our plant top NG 2.0, is more steerable, because we actually can postpone our irrigation further if we have wanted. At this moment, the plants were in the same bay, but if we have wanted, we could wait with the NG 2.0 and actually give more generative action to our plants. So then we go to the uniform distribution of water content and EC over the height of the block. So this is actually one of our lab measurements that we also did. This one is for our plant top block, so plant top NG 2.0. You can see that we saturated the block, let's say, till 50%. Then we have a middle layer of 50%, a bottom layer of 55%, and a top layer of 45%. And it's actually, yeah, we still work with gravity. So gravity is a force where we can't really do anything about. But we're sort of managing the whole situation. At least we are trying. But what I also said, the low standard deviation regarding water content and EC is also very important. And it's not only within the propagation phase, but it's also at the production phase. So actually, one of the things that we see the last years is that there is a more focus also for the production guys. So actually the customers of the propagators regarding, let's say, the block choice that they have. So and what we as Grodan also very believe is that we need to have a low standard deviation for precision growing. And that's not only within the propagation phase, but that's also for the whole production cycle. So until the plant gets removed together with the slab, the plant or the block and the slab needs to perform. And that's very important for us as well. And we think with plant top we really well manage that. So yeah, what does that look like? So here on the left side we have a picture of, let's say, a non-capillary wool, and on the right side NG 2.0. I know it's a picture, but we've seen this in practice as well. So we have, as I said, a lot more root development in the top layer within our slabs, but also a lot more root development within our top layer of our blocks, also within production. Whereas, let's say, versus a few years ago, where we had less root development here, and also less at the top of the blocks. And if we also look at, let's say, other stone wool products, we believe in that we need to have roots that go directly into the slab. So what I said about those pen roots, they need to be healthy, they need to be there. Rather than going to the outside first, which looks very nice, but then go from the outside into the slab where we have strange EC values here, strange EC values here, and tilting of blocks during the production phase as well. So then we go to, I believe, another poll question. So then, Thomas, if you want to come back.
Yeah, that's already the last poll question of today. So again, please, people, take your phone, your smartphone, and what do you expect what happened in this situation? If we look to this picture, what happened at this propagator? Is it A, too high doses of pesticides are used, B, a lack of nutrients, or C, a bad initial wetting on the block line? So please give your thoughts, and time starts now. So 4, 3, 2, 1. Yes, and the results are. That's. I'm really happy to see this.
Yeah.
I think my colleague as well. So 90% think it's C, and more or less 9% think it's B. So Thomas, please give us the right answer.
Yeah, well, I think we have a very smart audience today. So yeah, it's actually right. It's answer C. So bad initial wetting at the block line, and that's also one of the things that I want to talk about after this. So what you actually can see, this is already in an early stage of cucumber propagation. So just after, let's say, germination, and we can already clearly see what kind of, let's say, differences there are within this plant batch. So we'll dive deeper on this now. So actually, what actions to take to benefit from these FABs, as we call it, as a propagator. So FABs, features, advantages, benefits of our plant-top block. So, and those are the two things that I really want you to take home and get to bed with and lay below your pillow. Initial saturation, so very important. Resaturation levels within the propagation phase as well. So we'll dive into that now. Yeah, initial saturation of the different sized block. Again, initial saturation is key when you want to use not only Grodan but stone wool products wide. In Holland we have a saying, it's een goed begin is half het werk. In English translated, a good begin is half of the work already done. And I really believe that's the case also within a propagation. Because you can also relate to, let's say, grafting or sowing. If one of these key processes is not done correctly, then you're already one step behind. And it will never be, let's say, the plant, you will never deliver the plant batch that you eventually wanted to deliver. So really, I want to stress, check regularly to ensure block weights are correct. So what does that mean? I have a table over here. I will not go into, let's say, detail of every size of block, but just to give you an example, a 10 by 10 by 6.5, a block volume of 650 cc, minimum volume of water per block that need to be applied. For us, that's an advice. But a minimum weight per block in wet conditions. So after initial saturation, a block of 10 by 10 by 6.5 needs to weigh at least 550 grams. If that's not the case, then there's something wrong or with your wetting line, or maybe it's on our Grodan side, but you really need to ensure that these numbers are correct and really check them regularly. As I said, the minimum volume of water applied per block, that's an advice, but I really would stress if you have to pick one of these, please go for the minimum weight after the block line, because that's the most safe one and you can never get wrong with that one. So what then about watering? I also said about the resaturation, that's also very important, and it's quite fun, now not quite funny, but it's some of the experience I had within the last years is that there are some propagators that do a real good job within the initial saturation at the beginning, but then they really, let's say, do not make use of our benefits of the product because of, let's say, bad resaturation within the propagation phase. So just to give you an example, it's a very, let's say, easy example, but just to also for you to understand, let's say this is a bay of plants. So here's, for instance, a concrete path here as well. We have here the outsides with, let's say, our walls, and within the middle we have our gutter, our let's say watering points where water will go out. So this is, let's say, an ebb and flood floor. When we, let's say, ebb and flood this floor, we have very good resaturation levels in the middle. But if we go outside, let's say to the outsides of the bay, but also at the concrete floors, we see that we only resaturate at, let's say, 450 grams. Whether we, in the middle of the bay, we resaturate to 550 grams. So that's a very big difference. What I said, I want to have a block that's here, let's say 50% water content, but I also want it, let's say, in the middle of the bay. And really, especially after resaturation, you should expect that those levels are, let's say, all green or all in the 550 range and not like this. So there are a few questions that you can ask yourself. Okay, I measure, let's say on the outside, I measure 450 grams, and in the middle I have the right values. What did go wrong? Did I, let's say, applied enough liters per square meter? Or is my standing time too long or long enough? Those are all questions that you, let's say, can think about and also must think about, because if this not on point, then your whole precision growing concept will not work as well. We want to see it, let's say, all green, but it's just something for you as a propagator to think about. And I also hope that this is something that you will take home with you. So then I think this was my part. I will leave this thing here again.
Thanks a lot, Thomas.
You're welcome.
Last presentation was that already, and that leaves actually time 20 minutes for the last part of this webinar, and that's the Q&A session. So I've seen some questions already came in, not too much. So if there's any burning questions or things that might have triggered thoughts in your mind that you want to verify, we have 3 experts on table. We have, of course, Marta Streminska here, who gave one of the presentations about my impact of microbiology. We have even Edward Thoren, digitally, but still present on the table. And, of course, also Thomas Dauma, who just gave the presentation for Grodan. And my colleague, Thomas Peters, he will take you through the Q&A session. So, Thomas, curious to hear about the questions.
Thank you, David, for your introduction. I think I will start. I have quite some questions, but I will start with Edward. Edward, can you hear me?
Yes.
Yes. Okay. The first question is from a Russian grower. How many people is needed per hectare in such automated system? If you compare it with the concrete floors.
Yeah, it's similar, but the plants are actually being brought to the people. So the limiting factor is actually the speed in which the plants are being brought. So for the future, it's always better to have more points where you can ship and do labor. But currently, we use around 26 people for our shipping and clipping.
Okay. I think that will answer the question. Another question for you, Ed. If you're going to build a new greenhouse, for what kind of system would you choose and why? Would you choose for the tables again, or concrete floor, or for the cascade floors?
Well, that is a tricky question. You do need a majority of your greenhouse to be concrete. But when it comes to the spaced out plants, and in the last few days before shipping, when your labor is highest, the table system helps make an easier type of labor. So if we were going to build more, I think we would do tables to ease our labor issues.
Okay, so but if you, correct me if I'm wrong, Ed, but if you need to ship, for example, 25 trucks, and every half hour we can do one truck, so the plants are standing then a long time on the cars, for the shipping. Is that a problem or not? What is your thinking about it?
Yeah, that would be a problem. Yes, we're only 5 acres currently, and as you build more table systems, you would develop more points of shipping. So you could also ship from different locations along the line, which would also speed up your process.
Makes sense. Yeah.
I think it's also a more question about whether it's like, let's say, from a growing perspective or from a logistic perspective where you talk about, because maybe within, let's say, the table system, you're more or less, as a grower, it's fantastic, but let's say in high peaks, it can be, let's say, limiting, or am I wrong?
No, that's 100% correct. Just like in the video, we have lots of positives to the growing end, the active climate, the healthy roots.
Yeah, makes sense.
But then when you do touch on some of the limitations with the moving of the plants throughout the growing area and the shipping, it's just something that comes with the benefits.
Okay, thank you. Then I have another question, but first I go to the other panel. This question for Thomas. A question from, I don't know from who, but what is better for checking the blocks on the water content on the block line? Is it weighing the blocks or checking the given number of liters of water?
Yeah, well, as I also explained, for me, it's nice to have both, but if you have to, let's say, choose one, please go for, let's say, the eventual grams of the saturated product. So let's say for the 10 by 10 by 6.5, the 550 grams, if you check that regularly, then you're good to go.
Okay, then I got another question from Olivier. And you are speaking about block watering, but what about the plug watering?
Yeah, it's a good point. Well, actually, as I explained as well, we now introduce, let's say, the NG 2.0 technology, actually the latest within our plug products as well.
Yeah.
So we also benefit from, let's say, the initial saturation, the fast initial saturation within our plugs as well. As you also know, we deliver different types of trays. So we have 252, but also 240. It more or less it also needs to be on point. Let's say if you want to have the numbers for the different types of trays, so maybe Olivier, he can send an email or something about what kind of product he wants to have, let's say, a number on, then we're more than happy to advise as well.
You can get it for sure. Another question for you, Edward. Do you, from Peter Reinders from Rijkswaan, maybe you know him, but do you fill the blocks on the table always back to 100%? That is his question. So I think he means do you stop at 70% or do you always resaturate your block to 85%? Or?
Yeah, well, by adjusting the flood time, you can change the amount of water in the block. Unlike a cascade or flood floor, there's no hold time. The water is actually moving through the plants and draining immediately. So the water only raises about 2 centimeters up the side of the block. So if you want to reduce the watering and stay in the drier zone, you just run it for less time, opposed to if you want to go 100% saturation, you run it twice as long.
Okay. I think that's the answer what Peter was looking for. Then I got a question for Marta, our lady on the table. What should a propagator basically have to take into account in order to prevent pythium?
First of all is, like I said, the pathogen-free plant material. So if you start from the seeds, you have to make sure that they're not contaminated in some way with pythium.
Yeah, makes sense, yeah.
Because they can maybe contain oospores. They shouldn't, but they might contain oospores. The second thing is when you water the plants, you have to make sure that this water is also not sterile, but it's been treated and the pathogens are not in it. So if you recirculate the water, for example, just make sure that the system for the disinfection of your water is running well and it's killing really the pathogens that might be recirculated. Also, do not overwater your plants because the more water, the more possibility for environment with a low oxygen content. Because the bacteria around the roots will be very active. They will be using the root exudates and therefore also using the oxygen around the roots. And in the system where there's low oxygen, the bacteria that survive without the oxygen get in and produce little rots, wounds into the root. And this way the pythium has a easier access to the roots and to go into the plant. So these are the very important things. The other thing is also using the chemicals. But a lot of chemicals are being phased out at the moment against pythium, for example. That's happening in the Netherlands. I do not know if is it happening in America or Canada and so on, but I suspect a little bit yes. And the last part is what we still don't know very much about, is biological control in rock wool system with microbes that we add. So the biopesticides on basis of bacteria or fungi. So
something to research.
Yeah. There are possibilities, but the thing is that you have to make sure that the microbe you're using, the product you're using, is compatible with your crop, because it has been shown that some microbes will not colonize very well. Even there are differences even between the cultivars of a certain species. So it's very important to be sure that the microbe is colonizing the root. Otherwise, it will stay in a system, but as a spore, inactive spore that doesn't do anything. And if it colonizes the root, it means that it's active and it's helping the plant to stay healthy.
That's an
and I think also one question from my side is that we, let's say, as Grodan, we also advise, let's say, in areas where they have, let's say, extreme weather conditions, to also limit the fluctuations between, let's say, you say very wet conditions, but also regarding, let's say, plant stress, so high temperature, low temperatures, watering when, let's say, the plant is suffering with cold water temperatures. Can this all have an effect on pythium infection as well?
Yeah. The higher temperatures means also the higher activity of the microbes around the roots. So it means that the possibility of pythium infection is also higher, because it is almost impossible to have a system when there is no pythium. Spores. So it is important to steer the system in a way that you actually prevent the real infection.
Then I go on to the next question. That's not for Thomas. It's interesting for you. But what is then the optimal steering range for the water content on EC for the right cluster development in the tomatoes?
Yeah, well, that's also a very hard one, because we all know that we have, let's say, a lot of variety within, let's say, tomato cultivars. So we have cherry tomatoes, beef tomatoes, vine tomatoes, etc. But I always advise to, let's say, you can steer more extreme on, let's say, the cherry ones. You have to take it a little bit, let's say, lay back on the bigger the tomato gets. It's not only with watering, but it's also with all the plant handlings, as we call them, let's say pinching, etc. Also with climate wise. But yeah, to give a rough estimate, I think we as a Grodan, we advise to, let's say, steer to for a beef tomato to a maximum minimum. So let's say the lowest that you can get to 40%. And with a cherry tomato, you can easily go to 30%, and nothing will happen to your cluster development. So,
thank you.
More or less that.
I think it's you answered the question. So, another question for you, Ed. What other challenges do you face with the new system compared to the ebb and flood system?
Well, the generative feel in the greenhouse is much higher. The airflow through the tables creates a very active generative plant. So when doing our planning, we need to either add days to plants to meet the cane size, as well as multiple spacings to keep these plants microclimate in a more vegetative state.
Makes sense, yeah.
Also, with some of the larger tomato varieties, you can go too generative, and it creates some types of twisted heads where you need to screen more aggressively, reduce your light, and maybe even water touch more.
Okay, thank you. I think, yeah. Then I got another question for Marta. A question from Angelica. What's your opinion in the summer production cucumber, how we can irrigate to prevent pitching?
Oh, that's a very difficult question. Yeah, of course, the summer production of cucumber has the highest possibility of pitching coming in. I know from the experience with Dutch growers is that indeed they sometimes, with the warmer days, they water a lot more compared to the day which is less sunny and not so warm. And that is also very tricky, because this also means that the pythium has more chance of getting into the system and getting into the roots. So basically what I would suggest is making sure that you have a strong plant. If you look for the biological solution, look for the product that really works with your plant. Apply it preventively. So even if the pythium will be present, it will be at bay. It will not infect the plant. That would be my solution. And just really look that you're not overwatering, because this is the biggest problem. That it can go very quickly. That the oxygen is low, and these bacteria attack the roots.
So actually, if we can compare it, so if you have to choose, let's say higher root temperature or block temperature versus, let's say, watering too often, so as you said, limiting the oxygen levels, then we actually need to lean more to, let's say, okay, we need to allow, let's say, higher block level temperatures compared to, let's say, we want to water because we want to lower the block temperatures. Is that correct? Or?
Yeah,
okay.
more or less.
Yeah.
Can you steer also then with the water temperature?
Sorry?
Can you steer then also with the water temperature?
Yes, of course.
Yeah, and what's then the maximum and what's then the minimum?
If you look at the pythium, the more you get into the 25-30 degrees of water temperature, the chance of getting more problems with pythium are getting higher.
Okay, thank you. But thank you, Ed. I've got some more questions, but for sure we can send them on email to you, to Thomas, to Matt as well. But we are almost there, and I think David wants to close this nice webinar.
Yeah.
So David, I give the word back to you.
Well said. Yeah, we are almost at the end of the session. So first of all, that leaves me to thank you all for dialing in. Worldwide, a lot of people have dialed in, and it also means different time zones. And know at least from Grodan that we appreciate all the efforts you took to dial into this webinar, even though it cannot replace the physical way. We hope that still for you this was a valuable event to join. For us, it was at least a pleasure to do. And with that, thanking you, I should for sure not forget to thank the people on table. To start with Marta from Wageningen University. Thank you for being here. Edward Thorne, of course, also, even though from a big distance, it feels like you're very close here on the table present. Really much appreciated that you were here. And of course, also my colleagues Thomas Daume and Thomas Peters. As a last message for those who are interested, after this session, of course, in the coming days, we will send you the presentations, and you can also expect to receive a recording of this webinar. And having said that, that leaves me to, again, to thank you for your participation. Wish you good health, stay safe. And I truly hope that next year that we will see each other physically again, and that we can truly shake the hands again as how it should be. It's now a bit different, but next time let's hope that we can do it the old-fashioned way and the most personal way. So thanks for that, and I really wish you a very nice rest of the day. Bye-bye.